Who dares to disturb me? Oh, Lord Vader. Yeah, no, it's me, Darth Aura. Really bad connection here. Yeah. What? A friend of foe detection system for Death Star? ASAP. Yes, of course we can do that. I will give that immediately to developer Samuel. Great guy. He can do this with automated tests and stuff. Yeah. What? No, of course I'm aware that this friend of foe detection is of enormous importance. We need it ASAP. Yeah, of course, business, yeah. No, you can totally rely on me, Lord Vader. I will teach that Samuel guy to really focus on the essentials. We ain't got no time for stuff like automated tests. No, I totally agree with you, Lord Vader. Lord Vader? He quit. So ein Schorfsäckel. And this is how I got my first task of the day. Welcome to my talk in these challenging times, and let me just share my screen now. So, can you see it? Okay.
We can see you, Samuel.
Okay, very well. Yes, my name is Samuel, and don't care for what is written on this slide. In reality, I am an Imperial developer stationed on the Death Star, and we don't have any time for this introduction anyway, so let's hop into our task. We are kindly asked to create a friend of foe detection for the Death Star. And of course, we are short on time and budget. We concentrate on just the implementation, and we should explicitly not create automated tests because we can't build them. Fortunately, we know very well how friends and foes of the Empire look like. For example, a red lightsaber means it's a Sith and therefore a friend. Blue and green lightsabers, however, mean it's a Jedi, and these are the enemies of the Empire. And of course, there are some folks that don't fit into either of these categories. In this case, our friend or foe detection should return unknown. So let's start implementing. Switch to the IDE. And here are listed all the indicators. Again, lightsaber color is a sure sign. A hooded robe is also a good sign. And we get all of this information with an object type, T-person appearance. We have everything here that we need. So let's just start implementing. We create a new package, Death Star Security, and then we just start to code. If a person data weapon type gleich lightsaber and a person data weapon color is red, then return friend, because this is of course a Sith. So let's compile that. Great, we got no compilation errors, but how do we really know that we didn't mess up? Let's just create some select from dual, and let's call our functionality. Death Star Security, friend or foe, and we give a person appearance as a parameter. Lightsaber is the first attribute, red the second, and the other two are not important at the moment. So let's see, and we get a friend back. Great, that worked. So let's go on. We have also Jedi, so we should create an else if branch for lightsaber blue. ePerson data weapon type lightsaber and ePerson data weapon color blue, return foe. So let's compile. I'm not sure, but maybe someone of you can stop the time because we can't build testing, right? So let's see. Oh, that didn't work. Maybe I have a typo. Yes, here it's of course lightsaber. So implement that, compile again, and then yeah, okay. Did you notice something here? Maybe you even are familiar, or this approach does sound familiar to you. Because when we develop, we are constantly checking. At least if we care for the result, we are constantly checking if what we just wrote is working. And this can be done with select. Sometimes we might use a debugger or a DBMS output. But these are all just different types of checking. And we could do all this in a more formalized way with utPLSQL. And utPLSQL, for those who don't know it, is a free open source testing software. It's actively maintained and has many integrations nowadays. And to start working with utPLSQL, you have to install it into the database, and it turns normal PLSQL packages into unit test suites. And this is how it's done. We create a new package and use so-called annotations. Suite means that this package is a test suite. And test means that the following procedure is an actual test. Inside this test, we can use several expectations and measures. And we pass an actual value into our expectation and compare it with different measures. There are a lot of different ones. The most common one is to equal. To run our tests, we can just call the public synonym utrun. So to do this checking in a more formalized way, let's create a new package, utDeathStar friend or foe, and you can already see here the suite and suite path annotations. Suite path is optional, and you can imagine it as some kind of folder structure for test suites. We also add 2 test annotations and 2 procedures. The implementation of this test is pretty straightforward. We really just call utExpect, then pass our DeathStar security friend or foe functionality into it and compare it to equal. And if we remember the thing we did before, select from dual, these 2 approaches are nearly identical. The only thing we changed here is that we replaced select from dual with utExpect to equal, and we also stored it in a package. Same goes with the second test. It's really the same, just with a different parameter. So let's do this in real. Let's switch to our IDE. And here you see exactly what we just had in the slide. So let's compile this. and compile this. It's really the same we just saw. And now let's run utrun with passing our test suite name or package name. I open dbms output here so we can see something. And if we run our test now, we get a pretty nice output. And you can see here how the names we pass into our annotations are reflected in the result. Here and here, here. So some of you might not very much like dbms output. And we can also call our test suites from utrun and select from a table. So we get the exact same result here as a result set. And now that we know what we need to do, we can enhance our tests with adding rules for ropes. I really like ropes. So this is what we already know. And let's add 3 new tests. And we give them expressive names like black rope means friend, brown rope means foe, and red rope means unknown. We don't know it exactly. We compile this, and here you see what we already got. And I changed the layout a little bit of our new tests, so you can see it's really always the same. We just pass different attributes and compare to different results. So no big magic in here. And if we now run our test, we get a lot of failures. Of course, we didn't implement any of that rope functionality so far. So you can see here, we have 2 successful tests and we have 3 failed ones. And the really nice thing here is that we get information about exactly where and what failed. And in case of an error, we even get the whole error stack back. So let's implement our functionality. And I don't want that we concentrate too much here. One thing is that we can really do major code changes because we can be sure we don't mess up any functionality, because in the end, we just run our unit tests and can be sure that all of this functionality that we scripted as test is still working. So now I wonder, where is the difference? We did basically the same thing, but in a different way. And this is a very important thing, that the creation of software and unit tests is as inseparable as programming and debugging. No one would have tried to divide the things we did in the first example into different baskets. No one would try to separate them and build them separately. And the creation of unit tests is actually a part of the software development process. So we should stop to treat them differently, speak about it differently, because it's really the same in a different way. But let's talk about what a test really is. And to understand what a test is, we first need to understand what a function is, or a functionality. And a function is basically the transformation of input into output. So if we want to test this transformation, we have to control the input and check it against an expected output. And this is exactly the same for each unit test. We always control the input, run the transformation, and check against an expected output. And of course, with our first example, this is very, very easy because we have very visible direct input that we can control. So if you wonder where is a good start to begin with unit testing, always look for deterministic functions because they are usually very easy to test and a good starting point. Oh, a very urgent message. We need a package which returns a welcome message based on the active defense mode of the Death Star. ASAP, what else? The message also depends on that new friend or foe detection I told you to implement. Oh, we are glad we already did that, right? Check attachment for details, Darth Aura. Yeah, thanks, Darth Aura. Let's just check this attachment. Okay, we have a welcome function, and this gets an input that we already know. It's a T-person appearance. And this should be passed to our friend or foe detection, and we also select from desktop protocols and from the active protocol. And based on these two things, we need to generate different welcome messages. Yeah, so far so clear, but I see a problem. This is state. And maybe you already stumbled over this sentence from the unit testing best practices. Mock out all external services and state. And rules like these make it so hard to get started with unit testing in the database. Because we are in a very different situation compared to languages like Java or C#. Because first of all, state is everywhere. A database is meant to deal and hold state. And second, mocking in Oracle is very hard, if not impossible. And therefore, we are finished with our journey unit testing in the database. Thank you for your attention. Joke. Yes, it's true. State is everywhere, and mocking is really nearly impossible. But controlling state in a database is relatively easy because that's also a core point of database. And if we can make sure that our defense mode has a certain value when we run our test, we achieved to control that input, which is the precondition for unit testing. So all state is basically indirect input. And therefore we can change this statement and we can say, instead of mock out all state, control all state. And let's do exactly this with our welcome functionality, of course, with the force. Let's look at the specification of our welcome function. What indirect inputs do we have here? And you might be surprised, but the first indirect input is in fact our friend or foe functionality, because we don't pass the result of this functionality to our welcome function. We pass the input for the friend or foe functionality. And then we rely on the result of this indirect functionality. But we already proved that we can control this, so we are covered here. The second indirect input is our active defense mode, or the active protocol with a defense mode, and we encapsulate this in a function. Let's have a look at this function, and this here is the important part. This is what we need to control: the tables Death Star protocols and Death Star protocol active. And to do this, we start with a new test package. You see again the suite and suite path annotation. You see down below the test annotation and also a new one. And before all means that this procedure setup protocol will be run once before all tests of this test suite are run. So it's a great place to set up our database for all upcoming tests. If we look at the implementation of this setup procedure, it's very straightforward. We really just insert a new protocol into the desktop protocols, which will be our dummy protocol. And you can see that we use here a negative primary key. This is only possible, of course, if you have identity columns which don't force auto-generated integers. But if we have this possibility, we achieve two things. First of all, we don't have any collisions with existing data. And second, we know exactly what primary key our dummy protocol will have. So we now just need to update our active protocol to be our dummy protocol. Let's make sure we really can control this indirect input with a first test. We update our dummy protocol ID -1 to have the defense mode be kind, and then we expect the result of active defense mode to be kind. And to increase our confidence in our code, we do the same with a different value. We pass be suspicious, and we also expect be suspicious. And when we now run our test suite, we get a successful test. And at this point, we can be sure that we are able to control our indirect input. So we have now two controllable indirect inputs. These inputs are, we already know, the one from Friendfo, and unknown. And at the moment, we have three different defense modes: be kind, be suspicious, and shoot first, ask later. Very important. And these inputs lead to a number of outputs or outcomes. We have welcome, we have die rebel scum, and in one occasion, we even just ask them if they are actually a Jedi. And when we develop new functionality, it's often a great help to create such a kind of input-output matrix, because we get an impression of the complexity, and it also reduces the risk to forget something. Let's get serious now and turn this matrix into a number of unit tests. And to group these unit tests by a certain topic, by the protocol, we use contexts. Contexts are a kind of suite inside a suite. They can hold their own context-wide annotations, like this before all, and they can also be run separately and so on. This is really just to group them together. Next, we control our indirect input. We have proven that we are able to do that with our negative primary key. And then we implement our actual test. And this is, again, really just UT expect, protocol security, welcome. And here we have our second indirect input. And to deal with that, we pass a specific attribute or a specific number of parameters that we know will lead to a certain result. And the result is again compared to via to equal to be welcome. And the other two tests are very much the same. We just replace some parameters and expectations. Now we can do this same for the other two protocols, and notice how these contexts and tests are named here. When protocol shoot first, ask later, friend is welcomed, foe is shouted at, etc. These names, they tell a story. And indeed, when we run the unit test in the end, we will get this very expressive output. And I can just read through the test results. Dev star security, welcome message. When protocol, be suspicious, friend is welcomed, foe is shouted at, unknown is asked whether they are a Jedi. And even if I am unfamiliar with the function, I get a very good picture of what this function is supposed to do. And in that way, unit tests can even serve as kind of documentation. Okay, that means let's automate all the things. That wouldn't be very pragmatic, because sometimes, especially in legacy situations, we don't create automated tests as part of the development process, and everything comes at a cost. So the pragmatic thing to ask here is automate the right things, or what are the right things? Which tests should we automate? And Angie Jones created a very, very useful model to approach this question. I recommend to watch her whole talk on this topic. I put it in the slides, and just go on and follow her on social media too, because she's really been one of the most inspirational developers to me lately. And Angie creates 4 criterions to determine whether a test should be automated or not: risk, value, cost efficiency, and history. And I replaced history by change probability because that fits more into the situations I'm usually in. And I can't go too deep into that, but I want to give you an impression of what the questions are that you have to ask when you are approaching these 4 criterions. Risk, how serious is the impact? And how frequently is the functionality used? Value, what new information do I get from a test? And how quickly would a failed test be fixed? Cost efficiency is how quickly can a test be written? And also, how easy is it to write a test? And the change probability is how often will the code change, like in a setting where much refactoring happens, and how rarely will the functionality change? Because if I have to change my test every time I change the code, it's not as valuable. And these questions give you a very good indication whether you should automate tests or not. But that's one thing we shouldn't forget: tests that are created as a part of the development process, like in TDD or like we did it in the beginning, they deliver a lot of their value during implementation, not as part of the test suite. So even if these tests have little value, it might be that they already provided a lot of value during the implementation of the functionality. Oh, another super urgent email. We need a change of room manager ASAP. Every room of the Death Star needs a security level default value 1. I expect this to be done today. Darth Aura. Okay, thank you, Darth Aura. I really wanted to finish for today, but let's do this. But what the heck is the room manager? I didn't hear about that. So let's have a look. Let's have a look. Okay, this is the public API of the room manager, and we can already see that we have 3 parameters, and 2 of them seem to be mandatory, because this is a subtype which holds a not null, and simple integer is also a subtype which comes with a not null constraint. The code, however, seems to be optional, so I don't need to pass it. Okay, let's look at the tables that might be affected here. Death Star sections and Death Star rooms. Okay, I see the code is filled in every occasion, and we also have this strange number in section that we are not able to pass to the public API. And what we would normally do here is to hop into the implementation and try to understand every single detail of the functionality. And because we want to be really sure we don't mess up existing functionality, we would then create unit tests for every little bit, one by one. But that's not necessarily a pragmatic approach because it can cost a lot of time. So let's try a different approach here and try to explore this unknown functionality through tests and secure the functionality on the go. And to do this, we create a new test suite. We can have a lot of test suites. Again, suite path, and test. So far, so good. And what we do here is also something we already know. We control our indirect input, and our indirect input is, in this case, sections, because we need them. We need to reference them. And what we do then is we just call our functionality under investigation with different parameters. Here we pass a bunch of parameters, the section ID and the code, and we also pass, or we also have a call of this functionality without a code. So let's compile that and run our test. And wow, we have a successful test that tells us nothing. So even if we look at the underlying tables, they don't show anything. And this is because utPLSQL will roll back any changes you made during setup and during test. So after the test, nothing is kept and everything is as it was before. But there is a tool we can use, which is a flag called force manual rollback. And by calling utrun with force manual rollback true, we can prevent this automatic rollback from happening. And if we have a look now, we see our created test sections and also the result of our test calls. And we can make this even more visible by removing all results that are greater than 0 in their section ID. And this is another example why this negative primary key strategy can be very useful. So let's look here. Our null code call still got a code, but automatically. And we also got some values here in number in section. That's already interesting, but let's investigate that a little bit further. And for we have an open transaction, we should not forget to roll back before we recompile our test package. Let's add another call to verify what we, or to further explore what we have already seen. Again, 2 more rooms for different sections without code. So let's do this, and let's again run our tests with a force manual rollback. if we look at the results now, okay, all of them got a code. All of them seem to start with test true and then get a counter, and no matter what section ID. So wouldn't it be very cool to have a possibility to script that current state that we just created by our test and test against it to be sure that we don't mess up any of the underlying functionality? Yes, it would be, and it's also possible with SQLCL and a little plugin I wrote for this purpose. And as if I had known it, I already have a SQLCL session open. So let's run the same test here with a force manual rollback true. Okay, it's done. And now let's see what we have from Death Star rooms where section ID $0. Oh, and we can't read that, so let's set a different SQL format, Angie console, and repeat. And now we have a readable result. And now we can select a different SQL format. The one that I have written and included. It's called select dual. The dual, and we also pass the parameter clipboard. And if we now select, we get this kind of result, which scripts all our current state into a kind of select value from dual union all, select value from dual union all. The result is also copied to our clipboard. So let's roll back here and change back to our IDE. And this is our test we had so far. And let's paste what we got from SQLCL. And what we see now is that we can open a cursor. This is a sysref cursor with our scripted state. And let's have a look how this is formatted. Think of it as a table. And then if you get used a little bit to it, it gets very clear what's happening here. And we also create a different cursor which holds our actual state. And utPLSQL can compare or can deal with nearly any data type, and it definitely can deal with cursors. So we again call utExpect to equal and just compare these two cursors. And if we now run our test, we get a successful result. Now I can tell you much things because never trust a test that didn't fail. So let's change a little bit here in our expectation cursor and run our test again. Oh, okay, and now it really failed. Let's see what the reason is. Our actual ref cursor has one difference, and it has a difference in the code part. And here utPLSQL shows its strengths because it really shows us exactly what is different. Now we have created a test that really gives us some confidence that we won't mess up. And from here we could easily expand the functionality, for example, by adding a new security level to our expectation. And we won't do that in detail. You can find the whole example with going on into into enhancing the test on my GitHub repository. But I hope it becomes clear how we can use this approach to very pragmatically dive into a new functionality and secure it. And what we did here is some kind of approval test. And instead of, compared to unit testing, where we really try to have a single test for each specific functionality, we just use a model, an overall model, which is also called the golden master sometimes. And we don't even know exactly what the underlying functionality is, but we know this model. And we compare this model to our actual state, our actual outcomes. And in case something is very different, we can be sure to get informed. This is a very different approach of testing, but especially in legacy situations, it's a very, very pragmatic and valuable way. And if you're interested more about approval testing, I highly recommend to read that linked article by Maarit Piehajärvi. She's also a great person to follow on social media and shares a lot of her experience around testing and development. So I hope I could encourage you to start with unit testing in the Oracle database. I hope I could give you some hints how to start and what really matters. And in case you want to know more about utPLSQL from me, there are upcoming talks, webinars, and even hopefully a workshop in German this time, but I'm sure there will be some more too. If you want to read on your own, you can see this demo. All of the scripts are in my GitHub repository. You can go to the utPLSQL website. There is a special page with resources. You can also follow my blog or follow me on social media. And yeah, thank you very much. Come to the dark side. We have utBebbers, which means stickers. So if you want to get one, just drop me a DM or an email or something, and we can get that to work. Thank you very much.
Yeah, thanks for the great talk. We have some questions.
Yeah.
1, 2, 3, 4 questions. The first one is, can you send the output to the logger package provided by Martin Sousa?
I'm not sure if that would be a very good approach, because you want to have loggers in your production environment, and you don't want to have your tests in your production environment. So it might be possible in general, but I wouldn't recommend it. So I really would need to know more about the circumstances.
Okay. The second question, which IDE do you use? Is there an IDE that has advantages for the development with utPLSQL?
Yes, there are two. One is SQL Developer. It has a plugin for utPLSQL, and for those who watched the talk of Thorsten Kleiber, he used it and showed it. And the one that I am using is JetBrains DataGrip, which also have a plugin for utPLSQL. It's not at the same maturity level as the SQL Developer plugin. I myself personally prefer DataGrip because I really, really like code completion and working with files and stuff. So that's my choice.
Okay. Next question. Can the test show the fragility of a GIF DB scheme? And what would you do in such case? Refactor DB with normalization?
I'm not sure if I understood the question. A GIF DB?
I think it's about if the schema in the database is very fragile, maybe due to legacy code. If normalization would help. If you think normalization would be a first step to help.
In general, normalization usually helps because it does one thing: it limits the amount of input. And as we just saw, the less input you have, the less possible output you have. So if you can limit the possible input, that's already a very big win. Can I show the fragility of a legacy database with utPLSQL? That's hard to answer in general. Of course, it can, but you can't say I throw utPLSQL at a database and it creates all the necessary tests and I can run them and see everything. If we use utPLSQL and unit tests, we really have to create each test because it wouldn't make any sense otherwise. We need to understand the functionality first.
We are running out of time, but there's a last question I would present. How would you deal with legacy code with tons, yes, tons of indirect inputs and indirect outputs per program unit?
That's the situation most of us are in, actually. The first thing is identify these inputs and outputs, because you need to have some output, and maybe it's some entry in a different table or something. You need to identify these, and then you can try to identify units that are independent, because maintainable software is always about dependency. And if you are able to refactor your code in a way that you decrease dependencies, you have a very, very good first step. And utPLSQL can help there, but it's not a silver bullet. And I guess there would be a separate and dedicated talk about such a topic because it's really, really huge.
Yeah, thanks a lot. Thanks for your presentation. Well, my sis, your job is done here. I will take over from now, and may the force be with you.
Thank you, and may it be with you too.